presentation. This is the latest Kickstarter project from Sam and Mike. The Internet of Things without the Internet. First, a little bit of background. Maple Lake, Minnesota is a small town nestled just west of Minneapolis on Highway 55. It's a perfect place for a startup to begin or be reborn. So start with a classic building. Our building happens to be the original Maple Lake Telephone Company. It was built somewhere during the late 1800s or early 1900s, and it's made from poured concrete with a brick facade. So here's the problem. Maple Lake is right in the path of the polar vortex, and we had a desire to be able to monitor the building and to be able to control some devices. But our problem is, besides the polar vortex, the building does not have a reliable data connection. So seemingly the solution is the Internet of Things, but without a reliable data connection for UDP to be transported over, how can we reliably use the Internet of Things? So we had the idea, is it possible to replace the UDP with SMS messaging? And it turns out there's already been some thought put into it. The encodings for CoAP over SMS are nearly defined, and there's actually a couple of draft documents that describe how this might be done. The process isn't all that complicated, and soon enough we had software replacing UDP with SMS. So the solution is the standardization provided by the Internet of Things. The only thing we had to do was turn the UDP messaging into optimized SMS, and the Internet of Things stack changed such that the UDP was gone and SMS replaced it. So now that we had the software pieces done, it was time to architect the complete solution. So what did we need? We needed some type of temperature probe, and we needed a system to be able to run the CoAP server. We started with the Dallas one-wire temperature probe, and we wrote and acquired software to run on a Raspberry Pi to do the CoAP server portion. That was great, but we were still missing one piece. We produced a small Dallas one-wire to Raspberry Pi adapter board that is about postage stamp size. It fits nicely on the Raspberry Pi. And then we're missing still another piece. We wanted to be able to monitor the device, and it turned out the software actually runs on ancient Android devices where we could put our optimized SMS CoAP gateway on top of. And to complete the solution, we wrote another application that ran on a modern Android device with the CoAP application. So basically what happens is the modern Android device will field a user request, send an SMS message to the ancient Android device. The ancient Android device will send a CoAP message to the CoAP server running on the Raspberry Pi. The Raspberry Pi will query the Dallas one-wire temperature probe, determine the temperature, return the value back to the ancient Android device, and the ancient Android device will forward over SMS the temperature information that we wanted. And there's more. We didn't have to be limited simply to the temperature probe with the Raspberry Pi. The CoAP server on the Raspberry Pi can do anything. It can talk CoAP to other devices, obviously, but we can use things like curl, and we can use the Raspberry Pi to control 110 volt power devices. So for example, we could turn heat on and off as necessary. Using curl and CoAP, we have a powerful combination. We can control devices that were never standardized to the current Internet of Things protocols. But there's still more. Besides monitoring temperatures, we can actually attach an A to D converter to the Dallas one-wire board and monitor even more sensors. So what are we offering? Our Kickstarter is offering the Dallas one-wire adapter board for the Raspberry Pi. We're offering Raspberry Pi CoAP server software. We're offering Android CoAP client with optimized SMS software, and this software will run on even the most ancient Android devices. And we're offering an Android application using the optimized SMS software to talk to the ancient Android device. I thank you.